Hi everyone, this is Hossein from EJ Academy, and today I'm with Amir. Hi Amir, how are you today?
Hello, Hussein. I'm good. How are you?
I'm good, thank you, thank you. Today, Amir and I are going to review a limit problem. This time the topic is L'Hopital rule. Amir, the question that I have for you is finding a limit of the equation that you see on the screen using L'Hopital rule. So the limit is, you're going to find the limit of 1 minus cosine of x, the whole expression as to the power of sine of x. Find this limit when x approaching 0 from the right side.
Yes, sure. Okay. Here we have 1 minus cosine of x to the power of sine of x. In my experience, whenever we have something like, a function to the power of another function, we may use a natural logarithm to get rid of the power.
Can you first explain, what if you substitute x with 0, what you're gonna get that you need to
Yeah,
like manipulate this and use L'Hopital rule? What's the reason you cannot just find the limit?
because for example, here we have
Uh-huh.
1 minus cosine of x when x approaches to 0. So it's
Mm-hmm.
going to be 1
Mm-hmm.
to the power of sine of x when x approaches to 0, which is 0. So it is
Mm-hmm.
0 to the power of 0.
Mm-hmm.
So we know that when we are asked to use a L'Hopital rule,
Mm-hmm.
we have two general indeterminate form, which are, let me just,
Yeah, if you can write down the
yeah,
forms that basically you start thinking using L'Hopital rule to find the limit.
yes, yeah,
What are those forms?
two indeterminate forms which we can use L'Hopital.
Mm-hmm.
Those two forms are 0 divided by 0
Mm-hmm.
and infinity divided by infinity. So
Correct.
these
Yeah.
are the two general rules.
Mm-hmm.
And in the question, we are asked to use L'Hopital rule. So
Okay.
as you mentioned, the form here is 0 to the power of 0. So we have to get rid of the power.
Mm-hmm.
So we want to change that to one of these forms.
Right.
So that's why I'm gonna use natural logarithm
Mm-hmm.
to get rid of the power.
Okay.
So
Sometimes
yeah,
you explicitly you don't see these two forms when you
yes,
want to
yeah,
find the limit, but if you somehow manipulate the expression, you can get to that form, you can convert it to that form, and then you can use L'Hopital rule.
that's an important note to
Okay.
mention.
Okay.
Correct. Thanks for mentioning that. So if I just call this y,
Mm-hmm.
uh, then y equals 1 minus cosine of x to the power of sine of x. So I'm gonna look at the logarithm form. Ln of y is equal to ln of 1 minus cosine of x to the power of sine of x.
Mm-hmm.
So then we have sine of x times ln of 1 minus cosine of x.
Right.
We know that when we have ln of x to the power of n or whatever,
Mm-hmm.
then n goes to the next to this
Right.
logarithmic function.
Yeah.
So then we take a look at the limit of both sides.
Mm-hmm.
Uh, So limit of ln of y when x approaches to 0 from right side is equal to ln of sine of x, limit of sine of x times ln of 1 minus cosine of x when x approaches to the 0 from the right side. So we are going to manipulate with the right side of the equation here.
Okay.
So right now we have actually this one is 0 and this one is ln of 1 minus cosine of x is ln of 0, which is in limit terms, in limit sense, we have negative infinity. So
can you tell us why it's negative infinity and not positive?
Yeah, because if we look at the curve, write it here. If this is x, this is ln of x, then the curve is something like that.
Right, that's the curve of ln of x.
Yes. So as you can see, when first of all, ln of x is defined on the right side of the x-axis. So in other words, x has to be positive. So when that's the reason we have this one, the positive side.
Okay,
the right
because
side
the negative, the left side is undefined.
Yes, correct. So, okay, here we have 0 times infinity, correct?
Right.
So I'm gonna get to one of these forms.
Right.
So what I'm thinking of is actually using this form. So I actually transfer 0 to denominator like that.
Okay.
And then I get 1 divided by 0 is infinity. So I get
infinity over infinity.
Yeah, this form here.
Okay.
So given that, I'm going to transfer sine of x. I'm going to move it to the denominator.
Okay.
Because 0 here belongs to sine of x.
Right.
So let me write that. Let me get rid of these here. Equals. I'm just dealing with the right-hand side of the equation here.
All right.
Yeah. And then cosine of x, 1 sine of x. So I just moved it to the denominator. So since, as I said, we have infinity divided by infinity, we can use L'Hopital rule here.
Right.
So then,
which is basically instead of finding the limit of this expression, you can find the limit of another expression, which is
the derivatives of the numerator and denominator.
Right.
Given the fact that both numerator and denominator functions are differentiable.
Right,
and,
at that point.
Yeah, yes. So now I'm gonna take derivatives of numerator and denominator based on the L'Hopital rule. So ln of 1 minus cosine of x is minus, let me write it here as a side, ln of
Yeah, that's a good reminder.
U, y prime in terms of x is u prime over u, correct?
Right.
So here, this is u, 1 minus cosine of x. So u prime is minus, I'm sorry, let me just, minus sine of x, because cosine of x is minus sine of x.
Right.
And then divided by u, 1 minus cosine of x.
Correct.
That's for the numerator.
The numerator, right.
For the L'Hopital rule. We go to the denominator. We have 1 divided by sine of x. So
we can use quotient rule.
Yeah, quotient rule. When we have f.
I think we have a video on our channel about the quotient rule for those who wanted to refresh their mind about it.
Quotient rule. So based on that, it's going to be the derivative of 1, which is 0 times sine of x, 0, minus denominator, derivative of denominator sine of x, which is cosine of x, times 1 cosine of x, and then sine of x to the power of 2. So I'm gonna simplify this one. So it's going to be this times this, which is, let me write it down on the next line.
Yeah, it's better to go next line. You don't have that much room.
So x, so it's going to be sine to the power of 3 divided by cosine of x. We have a negative sign here, so I'm gonna put it here, times 1 minus cosine of x. So this negative sign is actually this one.
Right.
So
now you want to replace x with 0, see what you get.
Yeah. let's see if we get a determinate form. Here we have sine of x to the power of 3. When x approaches to 0, it's going to be 0. In the numerator, in the denominator, we have cosine of x. When x approaches to 0 is 1 times 1 minus cosine of x. So it is again 0 divided by 0. So, okay. We can say we want to use another L'Hopital rule, because we can use many times as we want. Right. But looking at the trigonometric functions that we have here, I think we can simplify without using L'Hopital rule.
Okay. How are you gonna do that?
Yeah, let me. Okay, x approaches to 0 to the right, from the right. So minus sine of x, because this one can be written as sine of x times sine of x to the power of 2, correct?
Right.
So I'm gonna actually times sine of x to the power of 2 cosine of x, 1 minus cosine of x. From trigonometry, we know that this guy is 1 minus cosine of x to the power of 2. Okay, so I'm gonna simplify as this. Sine of x times 1 minus cosine of x to the power of 2. cosine of x, 1 minus cosine of x. Then from algebra, we know that when we have like a squared minus b squared, when a and b are not equal, or they can be even equal, a minus b, a plus b. So we have that from algebra, correct? So given that, for this one, we can write 1 minus cosine of x, 1 plus cosine of x, because this is 1 squared.
Right. Yeah.
So
those terms are squared, so
yeah,
can use the factoring.
So I'm gonna write it like minus sine of x, 1 minus cosine of x times 1 plus
cosine of
fx.
Right.
And then cosine of x, 1 minus cosine of x, when x approaches to 0 from right. Okay, since 1 minus cosine of x is a non-zero value. Why non-zero? Because we have a limit here. X approaches to 0 from right. So it's not exactly 0 because we cannot divide 0 by 0. It's an indeterminate form, as we know. So since we are dealing with limit conditions, we can actually cancel out these two terms here.
Right.
Therefore, we have limit of 1 negative sine of x times 1 plus cosine of x, cosine of x. Yeah, the only term in the denominator. Let me put it in the center. Cosine of x. X approaches to 0 from right. Now let's take a look at the limit value. This guy is 0. The parentheses, the bracket term is 2. This one is 1. So we have a determinate value here.
Okay. Yeah, it's going to be 0 divided by 1.
Yes, yeah. So we got rid of the indeterminate form. I'm going to just put the values and I don't need to write the limit anymore. So it's going to be 0 times 2 divided by 1, which is going to be 0.
Right.
Therefore, as you remember, we started from here, the left-hand side. So we showed that the left-hand side is equal to 0.
Right. The limit of ln of y.
Correct. Limit of ln of y when x approaches to 0 from right side is equal to 0. And from limit rules, we know that we can actually transfer limit inside of this function. Therefore, it's going to be ln of limit of y when x approaches to 0 from right side is equal to 0. And from the logarithmic rules, we have limit of y when x approaches to 0 from right side is equal to e to the power of 0, which is 1. I think we solved the problem. Therefore, limit of, and y is equal to our function here. So limit of 1 minus cosine of x to the power of sine of x when x approaches to 0 from right side is equal to 1. And that's the solution of our problem. So the limit value is 1 here. It's 1.
Okay. All right. Thank you, Amir. Appreciate helping us, understand this problem. For the viewers, that is all for today. If you enjoyed this video, please consider hitting the like button and also subscribe to our channel for our future videos. Until next time, bye everyone. Bye, Amir.
Bye. Thank you.